Geometry benchmark 2.3, triangle inequality and the Pythagorean theorem. First problem asks us to determine if these could be lengths of sides of a triangle. Triangle inequality says that the sum of any two sides must be larger than the third side. So essentially, the 2 plus the 4 must be bigger than 6, the 2 plus the 6 must be bigger than the 4, and the 4 plus the 6 must be bigger than the 2. Now if you look at the second two, the 6 plus the 2, for sure that's going to be longer because 6 is already larger than the 4. So we don't even have to try that one. And the same thing with the last problem. So we really only need to try the smallest two sides, or the shortest two sides. So is 2 plus 4 larger than 6? And that's going to be a no. It doesn't matter that it's equal to. If it's going to be equal to, there'll be, if this was a 2 and this is a 4, the third side connecting the first dot and the last dot to be 6 long would be right on top of it, so that won't form a triangle. Next problem, I'm really going to try the shortest two sides, so the 24 plus the 7. Is that larger or longer than 25? And that's going to be a yes. Third one, 4 plus 5. Is that longer than 6? Absolutely. And here, some people forget, they just want to add the first two. Be careful. You want to add the smallest two. So kind of a trick question here. So you do 5 plus the 4. Is that longer than 10? And that's going to be no. So to answer the question, it says which, if any, of the above cannot form a right triangle. So the first one, so I'll say Roman numeral I, and the fourth one are the no's. And then you have to say why. So say because, you can either say because the sum of the smallest two sides is not longer than the third side, and you can see all the work there, and that's fine. Or you can just restate the work. So because 2 plus 4 is not greater than 6, so put a slash through the greater than 6. And 5 plus 4 is not longer than 10. So that's, I'll probably just put a circle around that to make that stand out. B, which if any will form a right triangle, and verify it with the correct work. Well, the right triangle in a Pythagorean theorem here, we have the A and the B, or leg and the leg. So we need the leg squared plus the other leg squared to be equal to the hypotenuse squared. So you simply have to plug in all the values. So 2 squared plus 4 squared, does that equal 6 squared? So 4 plus 16, is that equal to 36? That's a no. For the second one, we have, I'll take the smaller two sides. Those are going to be the legs. Does that equal the longest side squared? This is 49. This is 576. And 625. You're going to need a calculator for those. That does turn out to be 625. So that's a yes. Not a whole lot of room to work here. The next one, 4 squared plus 5 squared. Does that equal 6 squared? So 16 plus 25, is that the same thing as 36? That's going to be a no. That's 41. And then I guess I'll write the last one down below. 4 squared plus 5 squared equals 10 squared. So 16 plus 25 equals 100. That's obviously no. So go back, we only have one. So circle it, point to it, say that's the one that works. And then the work speaks for itself. Final problem, two sides of a triangle are 6 units and 10 units long. How long can the third side be? You take that 10 and that 6, add them together. That gives us the longest possible, and subtract them. That gives us the shortest possible, but it can't actually be those lengths because then we'd have same situation as above here where we had sides on top of the other sides. So the value of x, or the value of the third side, would be between those two values. So longer than 4. So you could write x is longer than 4, and at the same time it has to be less than 16. I prefer to write it in this form, between 4 and 16 units. Do not put or equal to, and that covers it.